Hello everyone, welcome to my course Introduction to Market Structures. So today we are going to do Bertrand competition with capacity constraint. Now we have already done Bertrand competition. What is generally done in Bertrand competition? In Bertrand competition we have two firms and each firm chooses a price, and the firm which sets the lowest price, everyone or all the consumer buys from that firm. So there is a competition to set the price, and we have seen that when there is no fixed cost and the marginal cost are same, both the firm set the price as at price is equal to marginal cost, and that is Bertrand paradox. Next, when there are fixed cost, we have seen that there is no pure strategy Nash equilibrium, and when we have different marginal cost and zero fixed cost, at that in this situation also we see that there is no pure strategy Nash equilibrium. Now we introduce a new thing in this Bertrand competition, and that is capacity constraint. What do we mean by capacity constraint? Capacity constraint means that the firm cannot produce whatever amount of output it wants to produce. It has some constraint on the output it can produce. So to study this, we have taken a duopoly market, that is there are two firms, firm 1 and firm 2. Both the firm produces homogeneous product. That means the output, whether I buy from a consumer buys from a firm 1 or firm 2, it does not matter. Both the firm produces same type of good. Okay? And since each firm sets price, so it is a Bertrand competition. Both the firms set a price. And now we specify the capacity. So each firm has a capacity constraint, that is K1 for firm 1 and K2 for firm 2. What do we mean by this capacity constraint? That means that firm 1 can produce maximum K1 units of output. So it is given by its capacity, and firm 2 can only produce maximum K2 units of output. It cannot produce more than, firm 1 cannot produce more than K1 units of output, and firm 2 cannot produce more than K2 units of output. So that is, so this is given as capacity. Now we specify the cost. So here we assume for simplicity that the cost is 0. For firm 1, for producing K1 units of output, its cost is 0. So it does not incur any cost to produce its output. This is actually a to simplify the game computation that we are going to do later on to find the Nash equilibrium, we make this assumption. Similarly, firm 2 to produce K2 units of output, it does not incur any cost. Okay? And the market demand is a linear downward sloping demand curve, and that is this. And more or less we have assumed this demand curve till now. So this is our demand curve. Now here, since each firm has a capacity constraint, so they may have to do something called rationing. And what do we mean by that? So it is, suppose price of firm 1 is P1 and price of firm 2 is P2, and price of firm 1 is less than the price of firm 2. Okay? So this is. So what will happen? Everyone will want to buy from firm 1 because the price of firm 1 is less than the price of firm 2. Suppose the aggregate demand, a market demand at price P1 is this, and it is such that the demand is more than the capacity of firm 1. So firm 1 cannot satisfy the demand that is generated in the market. So firm 1 cannot sell to every consumer that is demanding at this price. So it can only satisfy the demand of only a fraction of that or some portion of that. Some will be left untouched or will not be served by firm 1. So firm 1 has to do something called rationing. So it is something like this. Suppose you have 4 chocolates and you have to distribute it among, suppose, 7 children. Now you cannot divide this chocolate. So, these 5 chocolates, how you have to? You have to choose 5 out of these 7 children. How are you going to do it? You will use some rule. So, here also we will specify certain rule to ration, how to select which consumers are going to get this product from farm 1. Okay. So, we have to specify a rule, and one rule is this efficient rationing. So, efficient rationing says that those who value the good most, they are going to get that good from the low price farm. So, in this case farm 1 is going to serve the demand of those consumers whose demand or whose valuation is highest, a maximum. And what do we mean by valuation? It means the willingness to pay. So, it means those whose willingness to pay is maximum or is highest, they are going to be served first. So, in terms of, suppose in this case our demand curve is this. Suppose this is Q, this is P, in this axis P, this is A, this is A. So, demand curve is this, right. These heights are giving the maximum willingness to pay by a consumer. Okay. Now, this is a market demand curve. So, this demand curve we have got from horizontal summation of individual demand curves. Okay. So, if we want this quantity, what is the maximum it is willing to pay? It is generally, if we take individual demand curve of individual person, then it is given by this height. But here for simplicity we will assume that suppose this only gives you that willingness to pay. So, there may be some consumers who are willing to pay. So, it may be something like this. There is this one demand curve, this is another demand curve, and we have got the market demand curve from horizontal summation of these 2 demand curves. So, these demand curves, everyone, so each individual whose demand curve is this, their willingness to pay is higher than this, something like this we will get. Okay. So, here, so capacity of farm 1 is this, and we have assumed that this is the situation, suppose. So, everyone wants to buy from farm 1 since the price is less, but farm 1 can only sell this much amount, only satisfy this much quantity demanded. And what is quantity demanded at this? It is total demand is this. So, from this demand curve, what do we get is so first k units are going to be sold to those who value the goods maximum. So, this demand curve is something like this. This is the residual demand curve. Which is faced by farm 2. So, farm 1 is always going to sell this much at each prices. So, if the price is below this price, then only it can sell its full capacity, that is K1. Otherwise, if the price is here, then it will be able to sell only this much amount of quantity, if here it is only this much. So, for prices less than this, it is going to first sell this much. So, farm 2 whose price is higher than the price of farm 1 is going to get this demand curve. So, from this demand curve we remove this much quantity, and what is left is this, that is being served by farm 2. Okay. So, this is how the effect of rationing. So, what we do that when price of suppose price of farm 2 is less than the price of farm 1. So, in that case here it will be something like this. So, if price of farm 2 is less than price of farm 1. So, in that case so farm 2 is going to sell the first K2 units to those who value it maximum. This is the residual demand function of firm 1 in this situation. This. So, this is A minus K2 minus P. Okay. So, P is here, Q is here. Okay. So, now I hope you have understood what do we mean by the rationing. So, rationing here, when the moment a firm rations, it means it will only serve those consumers whose valuation is high. Now, how they are going to identify that, we are not bothered about it. So, we are not modeling it. So, that is a very valid question and it is a very difficult question also to address, but we are not addressing it here. We have addressed such kind of thing when we were doing price discrimination in the case of monopoly market, but here we are assuming that suppose farm 1, if it sets a price lower than the price of farm 2, it can identify the buyers who is valuing more and who is valuing it less. Okay. And if farm 2 sets a price lower than the price of farm 1, then it can identify the buyers in terms of their valuations. Okay. We assume that. So, now we come to the demand function of each firm. So, demand function of firm 1 that it faces is, so its quantity demanded is Q1, it is equal to minimum of K1 if P1 is less than P2. If farm 1 sets a price less than the price of farm 2, it can either, so total demand is A minus P1, since the demand curve is A is this, right. Now, its capacity is K1. So, it can satisfy the demand of K1 or whichever is less than this. Okay. And it is min K1 A minus P K1 plus K2 if P1 is equal to P2 is equal to P. So, if both the firms set a same price, that is P, then either each firm sell its capacity K1, if the total demand is less than its capacity, then it is shared proportionally based on their capacity, it is this. So, this is the demand at price this, and if so, this is proportionally shared. So, out of this K1 fraction of this whole capacity is going to be served by farm 1, and the next is K1 if firm sets a price which is greater than the price of farm 2, then either it sells its full capacity, that is K1, or it serves only the residual, whichever is less. If the residual demand is less than its capacity, it only sells its residual demand. So, this is the quantity demand that the firm faces in this kind of Butler competition with capacity constraint. Okay. So, we have considered all the possible cases here. Next, similarly for firm 2, we get Q2 is equal to mean K2 or A minus P2 if P2 is less than P1. So, if P2 is less than P1, then it serves the whole demand at P2 is this. So, either it can sell this much amount or its capacity, that is K2, or it sells K2 if price of firm 1 and firm 2 are same, and that is suppose P, then either firm 2 sells up to its capacity, or if the aggregate demand at that price is less than the aggregate capacity, then its capacity, then it sells this fraction. Okay. And when it sets a higher price, either it sells its capacity or it sells up to sells its residual demand if P2 is greater than P1. Okay. So, this is the demand curve faced by firm 2. Now, we will specify different values of K1 and K2, and based on that we will specify different combinations of K1 and K2 to solve the to find the pure strategy Nash equilibrium. So, before doing that, let us first look at the Cournot reaction function of this in this case. So, profit of firm 1 can be written in this way. If K1 is like this. Now, so this is the Cournot profit function, and provided these are satisfied, then optimizing with respect to K1, we get, so first order condition gives us, so this is the Cournot reaction function. From this reaction function, we can derive another reaction function, and it is of this nature. Suppose capacity of firm 2 is K2. Okay. Then what is the best response? Suppose firm 2 is producing at its capacity K2. What is the best response of firm 1? Best response of firm 1 based on this is this. So, this we can write in this way as the reaction function of firm 1 when firm 2 is producing at its capacity. So, now plug in different values of K2, different capacity of firm 2, and you will get the best response of firm 1. What is the best capacity it wants? This, or it wants to produce, it is this from the Cournot thing, right. So, we will require this, remember. Next, profit of function of firm 2 in this Cournot, if we take this is the aggregate price, this is the market price, and this is the output given this, since 0 cost, so cost portion is not there. So, first order condition gives us this. So, this is the reaction function of farm 2 given output of farm 1. So, now suppose the capacity of farm 1 is K1, you plug in the capacity here of farm 1, suppose it is producing at its capacity, then the farm 2, the best output or best response of farm 2 is given by this function, and this is. So, plug in values of capacity of farm 1 and you will get the best response of farm 2 this, right. So, these are the. So, now we will define the capacities based on these two reaction functions. Okay. So, if we simply plot these reaction functions, this. So, Q1 Q1 comma K1, Q2 comma K2. This is A and this point is A by 2, and this you can say this from this here. When this is equal to 0, that means K2 is A, K2 is here. For each K2 we get, and when K2 is 0, this is A by 2. So, we get this. Similarly, the reaction function of this is A and this is A by 2, and this is reaction. Plug in the value of K1, we get the best response of farm 2. When K1 is 0, this K1 is 0, this is equal to A by 2, this is this, and when this is equal to 0, so it is A, right. So, when K1 is A, this is equal to 0, you can say. Now, so this, hope you are following what I have done. Now, we specify the case. So, first case is this, that capacity of farm 1 is always less than equal to this function, this reaction function of farm 1, and capacity of farm 2 is always less than equal to this reaction. That means, here if farm 2 is producing at its capacity, that is K2, the capacity of farm 1 is such that it cannot be more than its best response. So, that is why it is this. So, in this situation, if this is A and this is A by 2, you plug in any value here K2, you will, the K1 is here. If it is K2 is this, K1 is this. If K2 is this, K1 is this, K2 is this, K1 is this. If K2 is 0, K1 is this, A by 2. Okay. Similarly, this, if farm 1 is producing at capacity, the capacity of farm 2 is such that it cannot be more than its best response. So, K2 is, so it is something like this. So, plug in here, suppose this is the capacity of farm 1, if it is producing here, farm 2's capacities should not be greater than this. If capacity of farm 1 is this, capacity of farm 2 should not be greater than this. So, it is from here. Okay. So, output of farm 1 here, output of farm 2, or capacity of farm 1, capacity of farm 2, this we get as the reaction function of farm 1. Yes, we get reaction function of farm 2. Now, and in case 1, we have got this whole region and this whole region, but when we combine this, so what is the case 1 saying? Case 1 says that R1, sorry, R1, K2, this is greater than equal to K1 and this is K2. So, if I fix this K1, then the reaction function from this we will get, it should be here from this. So, K2 should be less than this. So, here in this region, and here if I fix suppose in here K2, then the reaction from this, it should be in this line. So, it should be less than this here. Now, if I specify a K2 here, then if we only have this, then it should be here, but take this K1, K2 should be less than this portion. So, that is why we will not include this portion and not include this portion, only this portion is in case 1. So, suppose let us mark it with a different color, this green color, this region is actually the case 1, this green color. Okay. Now, in case 2, we know that case 2 is this K1 is greater than equal to A and K2 is greater than equal to A. So, here this point is A and this point is A. So, this region is actually giving us case 2. So, case 2 is this. So, the market size is sufficiently big, so that both the firm can satisfy the or meet the whole market. Okay. Okay. And this portion is given by this case, this K1. So, suppose the capacity of firm 1 is greater than the capacity of firm 2, and if firm 2 is producing at capacity, that is K2, the capacity of firm 1 is such that it is more than its best response. It is like this, and firm 2 cannot serve the whole market when price is 0. So, case 3 is, so this line we will get this is the 45-degree line. Now, here case 3 is, we have defined that there are two parts, case 3A and case 3B. So, 3A is R1 K2, this is less than K1, K1 is greater than equal to K2 and K2 is less than A. So, this portion is obviously, and this portion is also part of it, because this R1, if you fix K A, it has to be greater than. So, this points is satisfy this point, these points. So, we get this line. Okay. This is case 3A, and 3B is given by this region. This region is 3B, and 3B is, it is this, I am writing 3B here. So, it is K1 less than equal to K2, K1 is less than A, and R2 K1, this is less than K2. So, this portion. So, this portion also comes. So, these are the 3 cases, and in case 3 we have 2 sub cases. So, based on this we have got what? We know all the possible combinations of cases of K1 and K2 we have specified. Now, we have to find the pure strategy Nash equilibrium. So, that is what is going to be the P1 and what is going to be the P2 in this market, P1 and P2. P1, the strategy set is this 0 to infinity, P2 strategy set is 0 to infinity. Suppose we have this situation. Now, let us assume that there is a price and that is A minus this is P star. We have a price like this. In this case, we will definitely have a positive price like this, because in case 1 the capacity this is less than equal to this, which is equal to this, and K2 is less than which is this, right. So, we will have a price like this. Now, we will show that this is the pure strategy Nash equilibrium in this case. Now, if no, suppose P2 is equal to P star, okay, and suppose P1 is also equal to that price. Then the profit of firm 1, because it is selling K1 here and price is this. So, it is selling at this price and it is selling up to its capacity K1, and this is same as this. And here mind this, we will have a unique price here. Why we will have a unique price? Because our demand function is something like this. It is A P Q, it is A and this is A. So, it is a downward sloping straight line. So, if we fixed any fixed quantity here, you will get a unique price. If you fixed any quantity here, you will get a unique price. And at this price, at P star, demand Q is equal to K1 plus K2. So, if this is P star, then this Q is equal to K1 plus K2. So, it is such that both the firms can supply up to its capacity. It is not less than that, neither it is more than that. Okay? And here we see that the profit of firm 1 is this, if it is, and the profit of firm 2, is this, and this is equal to this. Now, we have to show whether this, we have to show that this is a pure strategy Nash equilibrium. Okay. So, how do we proceed? Here, let us assume that suppose let us P1 is greater than P star and it is equal to P2. So, if firm 2 sets a price P star, then suppose firm 1 set a price higher than this, then this implies what? Then it will firm 1 serves the residual market. So, the demand curve of firm 1, so the demand curve of firm 1 is K2 Q1, provided Q1 is less than equal to. Okay. So, if this is the case, then what is the profit of firm 1? Profit of firm 1 is this. Now, so there can be many such prices which satisfy this. We have to find that price which is the maximizing this. So, what we do, we are taking partial because in this case there is a strategic interaction. So, this profit is also a function of P2, okay, although it is not appearing explicitly, but it is appearing based on the condition, right. So, that is why, because this is the condition, right, this. So, that is why I am taking a partial. So, this is this first order condition will imply that it is this. So, if you plug in this price in the demand function of firm 1, that is the residual demand function, get this. Now, this is equal to Q1. Now, we know that this is R1 is given by this form. So, if firm 2 is supplying up to its capacity, then what is the best response of firm 1? It is given by this. And if firm 1 suppose charges a higher price and it is charges a higher price, so it is serving the residual market. In that case, what is the optimal price? It will sell. Optimal price is this, and optimal quantity it will sell is this much, right. So, this is when it is acting as a monopolist in the residual market, and this when it is given a capacity of firm 2, what is the optimal output of firm 1? It is given by this. Now, in case 1, we know that this which is equal to this is greater than equal to K1. So, in this case, what is happening? If a firm 1 sets a price, initially thinking that its price is going to be higher than the price set by firm 2, that is P star, then it is acting as a monopolist in the residual market. In that case, if it wants to maximize or it wants to set the monopoly price in the residual market, it set a price this and the output it sells is this. Now, this output is actually greater than equal to its capacity. So, it means what? Even if it wants to sell this much amount of output, it cannot sell this much. So, it will sell K1. Now, remember this, the demand function is of firm 2, firm 1 is this one, and this you can get this. Now, here when we plug in K1, here when we plug in K1, we get the price P star. So, this means what? And here the monopoly in the residual market, this is equal to this. Firm should be selling this much amount, should be producing this. So, and this is actually greater than 1. Now, if we plug in this here, we will get a price which is less than this. So, this means which is the this, which is the you can, I am writing this PM. This is suppose P1M. Okay, this is less than P star. Now, so here profit, because it will sell if it is acting as a monopolist in the residual market, this is the profit of firm 1 because it cannot sell this much. So, this is less than greater than equal to this here. So, it will be able to sell only this, and if it sets P star, its profit is this, and we have shown that this is less than this. So, that is why we get this. So, this means that profit of firm 1 is higher if it sets the price P star rather than trying to act as a monopolist in the residual market, because if it wants to act as a monopolist in the residual market, it will end up charging a price which is less than this P star. So, that is why this is not optimal. So, this strategy of firm 1 is not optimal. Now, if suppose firm 1 sets a price which is less than P, if P 1 is less than P. So, at P star it sells K 1. So, at P 1 Q 1 this will be greater than K 1. So, if this is the case, then profit of firm 1 is going to be P 1 into K 1, and since P 1 is less than P star, so is less than P star K. So, no tendency to reduce price below P star. So, we get that if P 2 is equal to P star, then optimal P 1 is P star, right. Now, we have to show whether it is a Nash equilibrium or not. So, again suppose P 1 is equal to P star. Okay. When P 1 is equal to P star, we have to find what is optimal P 2. So, we know if P 2 is also equal to P star, then profit of firm 2 is P star into K 2. Now, if P 2 is suppose greater than P star, then a firm 2 is A minus K 1 minus P 2. This it will serve the residual market provided K 2 is less than equal to K 2. So, we have to find the price P 2 such that it is greater than P star and also it is maximizing its profit, because there can be many such P 2s. So, P 2 profit function of firm 2 now is this. So, again optimizing with respect to P 2, we get this first order condition gives this. So, this is what? So, this is again the Cournot reaction output. So, if firm 1 is producing up to its capacity, that is K 1, what is the optimal output of firm 2? It is given by this here, which is equal to this. So, this is the M. So, we get this, and from here we get So, we get this. It is this. So, and we know that R 2 K 1 which is equal to A minus this is greater than equal to. So, even if firm 2 wants to sell this, it will not be able to sell, it will only able to sell K 2. Now, if it wants to sell this, it sets a price which is P 2 M, and P 2 M is equal to. So, at this price quantity it sells is it wants to sell is this. Since it is a downward sloping demand curve, the residual demand curve is also downward sloping. So, this since this is greater than K 2, so P 2 M is actually less than P star here. So, if that is the case, then profit of firm 2 when it sets P 2 M and sell K 2, this is going to be less than P star K 2. So, this is not optimal. So, we get that P 2 greater than is not optimal. For firm 2. Now, if P 2 is less than P star which is equal to P 1 which is set firm 1 sets that price, in this case profit of firm 2 is P 2 into K 2. This is definitely less than P star K 2. So, firm 2 has no tendency to undercut the price. So, from here we get that, so if P 1 is equal to P star, then P 2 is also equal to P star. So, therefore, this is unique Nash equilibrium in this case, and this is case 1. So, in case 1 we get that there is going to be a unique Nash equilibrium, and that Nash equilibrium is given by this case, this here. So, it is such that the price is equal to, price is such that it is the firms are producing at their capacity. So, P star is equal to this. So, this is the P star. So, when both the firms, firms are going to set a common price, that is P star, and at that P star the demand is such that both the firms produce up to its capacity. Okay. And this is the unique thing, because we have seen that there is no tendency of any firm to set a price higher than P star, neither there is a tendency to lower the price. Okay. And for the other cases, that is in case 2 and case 3, we will do later in the next class. Thank you.